call out your Scrum Master if they're not really doing things right. I know I've done that before. And then also, if you could please take a moment and sign in, I would really appreciate it. This helps to keep the Houston Java user going, so we can know that it is meaningful and well.
All right, well, good evening, good afternoon. I don't know. I don't know what time zone I am. I don't know what state I'm in. I'm not even entirely sure what country I'm in. Especially since it wasn't that long ago that I was at an improving location in a very similar kind of space. So I'm getting lots of deja vu and everything else. But what we're going to talk about today is the intersection of architecture and AI. It's a difficult one to talk about. So I'm going to take my own obscure little meandering path through this topic. So for introductions, my name is Michael Carducci. I'm an independent hands-on software architect. It says here I'm a holistic software architect. There's two reasons for that. One is because I've never really been good at explaining what it is that I do for a living. Even my family, not that, my birthday was 2 weeks ago. 2 weeks ago today. Thank you. I got a shout out on the airline. I was actually flying on my birthday. That made me either happy or sad that I fly so much that the airline wants to recognize me specifically as a passenger. They don't normally do that if you've ever flown on your birthday, so I think I just fly too much. And I got a phone call from my parents, and it was the usual kind of catch-up, really banal small talk that you get when talking to family that doesn't really know how to talk to you. My dad, my stepmother. My dad was talking to me, and then I hear in the background, "Oh, is that Michael?" And my stepmom, on the other side of the room, yeah, I'm talking to Michael. "Oh, hang on." And she runs over, picks up a different phone. It's the generation of my parents, they still have wired phones. They're getting the hang of this stuff slowly but surely, so I hear a phone pick up. "Michael, happy birthday, thank you. How's work?" We're doing all that. She said, "Are you still fixing computers for work?"
Yeah.
Yeah, I'm still fixing computers for work. So it's like they don't even know what I do. I'm not even sure what I do because even ostensibly, I'm an independent hands-on software architect. So what does that mean? I go to a client site and I do architecture. I work with Sahani. How much architecture have I done in the last 12 plus months? Like a little bit. I wrote some ADRs, I set up a documentation repo, but you're over there doing the C4 diagrams right now. Good job. The first thing I did when I came in there is a lot of times, as I do what I do, basically ever since I knocked on this gentleman's door, his office door, in 2014, I went, and Robert's like, "You always just barge in, what are you doing? Come in." And I did what I did. I laid down on the couch. I'm a big proponent of hammock-driven development. Or HDD, right? Anybody else? Just me? And that's, thank you. That's why, for the longest time, there's actually a plaque over that couch after I left. There's a Michael Carducci memorial couch, which is interesting being memorialized while you're still alive. But I can only imagine the conversations that have happened since then. Like new developers come in, they cycle in and cycle out. And so it's like, "Oh, so who was Michael Carducci?" "Oh, he was a dev who worked here, years ago." "Oh, what happened?" Quit his job to do magic full time. "Oh, did a magic trick go wrong?" "No, he's speaking in West Houston right now." So, but either way, I come in and I said these words. I said, "Robert, my heart's not in it." And he looked at me and said, "I know." And that was the beginning of the talk that is always awkward and uncomfortable. And I thought I was quitting my job to do magic full time, but instead I kept getting sucked into consulting engagements, and so that became my life. And what I learned in the process is that architecture is part of the equation. There are people in that equation. There are processes, practices, all these different technologies, all these different things intersect and enable or disable your architecture. And so the first thing I did, really, like one of the first things that I did, other than just trying to document the oral tradition of architecture decisions before the last original dev on the project left, the day I joined, by the way.
Oh boy.
Yeah, that was great. So it was like, all right, we're gonna have a talk. Is I set up DBOps tooling because like one of the challenges that was holding us back wasn't our architecture, it was our ability to be agile. And so I started building tooling and pipelines and things like that, and now that's all his job. You're so lucky. But that was like the first thing I did, and it's a lot of how it ends up working out. And so I look at architecture as part of something much larger, and that's where I kind of adopted this holistic thing. And that's kind of what we're going to talk today about in terms of architecture patterns for AI-powered applications. Because you're probably getting pressure right now from somebody high up the org chart with some highfalutin sounding title, likes to talk about synergy, things like that, and they're probably very excited about shoehorning AI into one of your apps that you're working on right now. Is that?
Little RAG and
yeah,
MCP and you know,
boy, I was picking fights on LinkedIn last night about MCP, but I'm not gonna go down that route just yet.
No, there is a neutron movie coming out in October.
Now that I'm excited about. That's the original agentic system right there.
Yes, the original MCP.
That's right. Actually, I have a whole separate talk that bizarrely enough is open, and I talk about MCP. You will appreciate this, sir, because you are a man of wealth and taste.
Thank you.
Oh, why did it start there? That's not where I wanted to start. I wanted to start. Oh, it took me all the way back to the first slide. That's cool. It's actually like slide on here.
OG MCP.
Yeah. So this is my slide that introduces MCP. And you know what? Every time I put that up, everybody looks at, what the heck is that? And every time that happens, I die just a little bit more inside. Anyway, this is a very long preamble, so I'm going to wrap it up. My point is, I want to set expectations. I'm going to take a different approach, kind of a problem-centric approach. I'm going to set a foundation. I'm going to take a more holistic approach to this topic. In other words, I'm not just going to dump a bunch of patterns on you. And that's really more of a reflection of you than me, because I am not somebody who is mature enough to be just handed a bunch of patterns. I remember the first time I read The Gang of Four. Anybody else? Yep. When I read that book, the very next day at work, I found a way to shoehorn every single one of those patterns into the code. This is going to be a singleton, this is going to be a visitor, and we're going to use the observer pattern here. I'm going to create a factory here, even though I don't need one, and so on and so on. So I'm going to, I assume everybody has or will have or tangentially has architecture responsibilities as part of your role, and I want to prepare you to operate effectively in this space. Now, what time do we have to vacate the premises?
9 after the latest. 8:30 would be ideal, but
Okay. All right.
8:45.
8:45. All right. This will be challenging. I'm going to talk fast. All right. Let's start with this idea of architecture. One of the things that I firmly believe is that architect is not just some new species of subject matter expert. It's not like, oh, you have expertise in everything, you have expertise in Java, you have expertise in React, whatever, and architecture is just a separate sub-specialization of IT, whatever we decided that means. It's really something that you grow into, you evolve into. Architects trade depth in a small number of areas for breadth, a much broader perspective when they look at the business and the problem and the domain and technology and the ecosystem and the landscape and the topology and all these different things. So this is what I want to give you. I want to give you a good enough foundation of architecture and AI, then we start to explore the intersection. And kind of as we go through, I want to see what kind of patterns emerge. But I don't know about you, but I find this to be a slightly perplexing question. Because in 2020, I don't know if you got the news all the way down here in Texas, but there were some things going on for a couple of months there. Every night at about 8 o'clock, we'd go out on our porch and howl at the moon. And then one day we stopped and we never talked about it again. Was that happening down here?
The oil bust, right?
That's right. That's exactly what it was. And so I found myself, my diversified stream of incomes between doing magic shows, doing speaking, doing public and private training, doing consulting, all of those things at the same time just sort of dried up. And I figured I had nice backup income, but I wasn't nearly as diversified as I thought because just about everything I did involved getting people together into one place, tight quarters, and that was kind of frowned on for a little while there. So I thought maybe it's time I get a real job, and I started looking for a job. And I saw tons of open architect positions, and and that's what I've been doing really for the last several years at this point. And every single one of them I was unqualified for. I keep using this word. Maybe it doesn't mean what I think it means. And the truth is, if you ask 10 architects, 10 people, you get a dozen different answers. And even in the narrow context of architecture and AI, there's a lot of different contexts that we can frame the discussion around hardware, infrastructure, data, services, components, things like that. So I never had a good definition, so I settled on this. Architecture is the essence of the software, essentially everything that it can do beyond the defined features and functions. So there's a near infinite number of ways you can write code to deliver a set of features. Not all of them are the same. And I don't just mean time complexity or space complexity. I mean in terms of the architectural characteristics, the architectural abilities. And this is important. These are the things that we have to think about. This is what it means to think architecturally. In fact, my friend Mark Richards often says, if you don't have the right architecture in place, if you choose the wrong architecture for a given project, generally the functionality is going to work, but the system as a whole won't be a success. Now, one of the things that I did, and I regret this decision to this day, is I built and I maintain a SaaS CRM for professional entertainers. I thought I was starting a business. I thought I would own a business. That's not how it turned out. In fact, my not technical co-founder and I parted on very unfriendly terms. And the last thing that I saw him post on social media before he blocked me was, if your technical co-founder assures you that your business is going to be turnkey, shoot yourself in the head twice just to make sure. See, here's the thing. If you're thinking right now, especially with vibe coding and everything else, I can vibe code up in an afternoon an entire product. Here's the reality. You don't own a business. You own a production support job. And that's what the rest of your life will be every single day. I was answering support tickets on the airplane because that's my life. But either way, the CRM is not just a CRM, it's really kind of a total business system for professional entertainers. It kind of handles everything from booking to scheduling to payment processing and reporting and your CRM and workflow automation, a whole lot of different things. Now, one of the big things this software does is it produces emails. It'll generate emails, it'll generate documents, invoices, contracts, riders, whatever you might need to dynamically merge in and send as an attachment to your client. And so I needed an ability to turn a template, in this case HTML, because they're all HTML templates because that's what I know, into a PDF. Now, there's three ways I could do this. One, I can roll my own PDF service. It's an open standard. It's well documented, but I'm not going to do it. One, I'm not that smart. Two, somebody's already done it. And three, whatever somebody else has already done has been used a whole lot more times than mine. I've learned the hard way, eventually, through bitter experience, that when you reinvent the wheel, more often than not, you reinvent the flat tire. And that's not fun for anybody. Option two, I can purchase a library that I can just drop into my application and say, hey, here's some HTML, and it says, hey, here's a PDF back. That's cool, but that required a large upfront investment. And I did not want to, I wanted no more large upfront investments. There were already too many, and I'm still in the hole 15 years later on this whole project, but that's a different story for a different day. That's a 5-year conversation right there.
5 years, wow.
Yeah, ooh, tell me about it. $100,000 is what I'm still owed by the business because I floated it for so long. Third option, I can use a SaaS PDF generator service that I can just make an API call. So that's what I chose because I could just buy pay as you go with the credits. Fantastic. And so that's an interesting question because now we're thinking about this because really we're thinking about functionality, right? Turning something into a PDF, generating PDFs, that's functionality. But are there abilities involved or is it just functionality? Is that just an implementation detail? Now at the same time, we have APIs that we can just send some stuff to and magic text comes back and sometimes it's useful. Is that functionality or abilities? Well, let's go a little deeper. Let's actually go deep. Let's talk about AI in general. It seems to suggest a lot. Intelligence. It implies intelligence. Now, out of curiosity, how do you think about AI right now? Do you think about AI as evolutionary or revolutionary?
Somewhere in the middle.
Somewhere in the middle? Okay, who's evolutionary? Okay, who's revolutionary? Okay, somewhere in the middle? Okay, okay.
I heard it. I read a good quote once, just recently, actually, that with AI you are taking average data and expecting above average results.
The definition of AI is taking average data and expecting above average results. That's a fantastic quote. I am stealing that, Jim.
I didn't come up with it. I just be like, oh, wait, does that make
Then I'm
sense?
stealing it from you, and you steal it. That's all creativity is anymore. It's just layers of theft.
So the AI would do.
That's exactly what the AI would do. I actually was so sad because I've been waiting for a new T-shirt for weeks. And remember the old piracy disclaimers on the VHS tapes? You wouldn't steal a purse, you wouldn't steal a car. Don't steal this movie, and the typography was all kind of edgy and gritty. It was this T-shirt was in the same style. It says, "You wouldn't steal the sum total of all human knowledge and creativity to power your proprietary AI model." I wanted to wear that shirt today, but instead I'm rocking UberConf. Thank you. That is Hayden Pickering, really interesting dude, posts a lot of stuff. But really, we've been working on AI for a long time. We've been thinking about this for a long time. In fact, we can go all the way back 75 years to 1950. In Mind, quarterly magazine for, actually it says my notes, a quarterly review of psychology and philosophy. That was this. And this was one of Alan Turing's famous papers on computing machinery and intelligence. And he was one of the first people who asked this question. Because remember, we've had computers more or less as we know them at this point for just a couple of years. And they were large, hot, noisy, programmable calculators and nothing more. The ENIAC, do you know how you programmed it? Some people say punch cards. Oh, no, we hadn't invented punch cards yet. Robert knows.
Tubes.
You actually had to connect different gates, logic gates, with jumpers. And that's how you would program it, because we hadn't quite figured out how to have instruction sets.
Do you know what the people were called?
No, I don't.
They were the operators.
They were the operators, okay.
Then, when software replaced the operators, it was the
operating system. Okay, I'm learning stuff today.
1 in 2,000.
But at this time, most people were just like, hey, this thing can do 2,000 calculations a second. And while everybody was blown away with that, Turing's over there asking the question, can machines think? And that is an interesting question to this day. But he went on to qualify this. He says, well, it really depends on what you mean when you say machine and what you mean when you say think. Because the definition of machine had changed radically in a short amount of time. We'd long been able to build computing machines, analog computers. That's a machine that would calculate the tides, since they were quite tedious to calculate by hand. This is a machine that can calculate the positions of the stars and planets in our solar system. This is a machine that can compute the initial settings of a 3-rotor Enigma device. They were all machines that performed narrow calculations. You build a machine and they could do one thing. And back in the 30s, Turing's over there thinking, I wonder if we could make a machine that could compute anything, any decidable problem. And he proved that it was feasible mathematically. Logically, you could do that. You could reduce all mathematical operations, any decidable computation, down to some kind of symbolic logic. Now, what he designed, the Turing machine, was not something you can actually build unless you've got infinite tape and infinite time and everything else, but he proved it was possible. It was a thought experiment. It was Claude Shannon that actually figured out how to make these machines. But a few years later, we had the ENIAC, one of the first, not the first. I'm sorry, I lived in England. I was like 5 miles away from Bletchley Park when I lived over there. And they are very salty about this because they kept it classified for 50 years.
Wow.
So America's like, yeah, we were the first. And England's like, well done, old chap. And they were staring daggers at us from across the ocean. But this was one of the first general purpose programmable electronic computers. But these just performed calculations, following instructions. And that was the question, is that their limit? Now, it was in 1955 that two gentlemen, Alan Newell and Herb Simon, started to play with this idea. They're like, yeah, could we do this? Could we simulate human reasoning and maybe simulate the process of human thought? And they had this insight that if you could take the interaction of simple, programmable units and combine them to accomplish complex behavior, potentially including the behavior of human beings. And Alan Newell got excited about this. He lost his mind. He got absorbed. He got sucked into it. And he has this whole thing. He says, I had such a sense of clarity that this was a new path. And when I was going to go down, I hadn't had this sensation very many times. I'm pretty skeptical, so I don't normally go off on a tooth that I did on that one, whatever that means. Completely absorbed in it without existing within the 2 or 3 levels of consciousness, so that you know you're working and you're aware that you're working on something important. And you're aware of the consequences and implications. Now, the normal mode of thought, no. Completely absorbed 10 to 12 hours at a time. And in 1956, they paired with a programmer named Cliff Shaw, and they created the first artificial intelligence program called Logic Theory. 1955, 70 years ago. And so people were excited about this. They're like, this proves that a machine can perform tasks hereto considered intelligent, creative, and uniquely human. Now, that was a proof of concept. So they're like, cool, that's our PRC, that's our MVP. Let's go to market. So a couple years later, they built the big one. Logic Theory is the prototype. The next one is called General Problem Solver. And this eventually, what they did was they figured out this approach of separating the rules of the system, the knowledge of the rules of the problem, and the strategy, the solver engine, and this ultimately became the SOAR AI architecture, which is still in use today. And one of the limitations of General Problem Solver is there's a combinatorial explosion of things to really kind of explore and evaluate all these potential options. Alan Turing wrote one of the first chess engines. Well, he conceived of the first chess engine. He actually kind of wrote the code roughly on paper, but there wasn't a machine that could do it. So he actually personally sat there and played chess with a very experienced and very skilled chess player. And he took about an hour per turn because he was actually manually running the program on paper. And because it's just some of these things are just too hard. So we need to figure out how to prune possibilities. Well, Dijkstra, at the same time was figuring out some things around that. His shortest path algorithm helped optimize searching in spaces. So we can program certain types of reasoning and evaluation of options. And since then, AI has just been steadily solving different classes of problems. We've been using AI in the broad sense, in the general sense, for decades, but it hasn't seemed as cool as it does now. But once we saw generative AI, that completely changed the perception. Because in the old days, like I was building, we were doing essentially AI stuff more than a decade ago when we were doing latent semantic indexing and semantic analysis of documents. We were really kind of pioneering a lot of the semantic search stuff in the e-discovery space. Robert and I were. We went out to Chicago and no, not Chicago. We went out to Virginia, Reston. We went to Reston and we were talking to people doing a lot of state-of-the-art stuff there. It was cool. But the things that are different, first of all, a lot of these you have to actually train these models. You take a model, you train it with some data, and you interact with it in a really rudimentary, kind of low-level way, and there was a whole lot of work I had to go to. But now, I can tap into a ready-to-go model. I can just download a Hugging Face, off we go. We can interact with these models now with natural language. That's revolutionary. AI itself, I'm not sure, but I think that's pretty revolutionary. And these models, they can do a lot of things. They can answer questions. They can generate code. They can generate images. Sometimes the monitors are facing the wrong direction, but I did recognize that was you in your LinkedIn post. So, kudos to the AI for that. So I'm going to focus on the Gen AI models for this session because people are believing there's a lot of potential in there, and maybe there is. The thing is, all the things these models are doing is a truly intelligent. We have the fundamental question, that is, can machines think? And Turing actually came up with a metric to measure this. How well are these things thinking? And he called it the imitation game. The Turing test, as we know it today. We know what the Turing test roughly is, but I'm going to give you a quick summary. And I'm going to answer this question of, is this truly intelligent? Because it turns out fooling humans is not necessarily a very useful metric. Let me explain what I mean. So the way the Turing test works, somewhere there's a room, physical or conceptual, but inside that room is a respondent. It could be a person, it could be a machine. That you, as the judge, can send questions to it or make statements and get responses back. So, for example, the judge could say, all right, you know what a human can do that maybe a machine can't? compose poetry, write me a sonnet, and the respondent comes back with, shall I compare thee to a summer's day? And then the judge says, okay, that's cool, but did you really write that? I kind of feel like you plagiarized it. See, we're foreshadowing at this point because this is an old example. Yes, there's a lot of plagiarization going on. So the judge says, your sonnet begins, shall I compare thee to a summer's day? Why not a spring day? I like spring. I actually like spring more than summer because I live in H-Town here and summer's kind of miserable. Spring's not so bad. Winter's nice. So that goes into the machine or goes into the room and the respondent, maybe it's a machine, maybe it's a human, we don't know, comes back with something plausible like, well, because it wouldn't scan. And so let's imagine, though, that you're not the judge, you're the respondent, I'm the judge. Or actually, you're the judge. So you're the judge. And you send the respondent a question. Robert, that's you in the box. What's the answer?
No clue.
No clue. I was hoping that you would say it's the same as what you get when you cross an elephant with a rhinoceros. Elephino. Yeah. By the way, thank you for chuckling, Scott. It's not going to get any funnier, so just settle in, okay?
We call a deer with no eyes.
What do I call it? What with no eyes?
A deer with no eyes.
A deer with no eyes. I have no idea.
No idea.
Oh, I was right there.
So close.
I was so close. But do you know what that says?
Yeah.
Okay, cool. All right, don't
What
tell
does
us.
it say?
Well, we'll find out. I'll translate it eventually. But I just think it's cool that you get that. That's like grammatically pretty good.
Yeah.
I can't do the tones. I get it all wrong. I say the wrong thing. But so imagine that goes in, and somehow, Robert, you are able to give a response. Is that the correct response? Okay. Well done, Robert. How the hell did you do that? Well, you see, you have a book, you have a cheat sheet, a vast volume that has the appropriate response to any conceivable prompt. Now, you have no idea what came in, you have no idea what came out, but you did it. And if you're the judge, you're like, well done, bravo, 10 out of 10. You passed the test. But zero intelligence went into it. Now, maybe instead of a book, it's a set of instructions and vast vector tables that you can do some weird, very computationally expensive arithmetic, floating point math, and you can just follow those because time doesn't exist. And that's what we've done. We've just baked something into the machine that allows it to do these things. By the way, not gonna lie, I use Gen AI to do all my translations, and it worked pretty well. Yes?
But could you argue that we don't really know, like, what if your brain is similar, right? Like, what is it? Is it not just like a difference in the source of where you're looking it up, whether it's in the book versus your own brain?
Well, yeah. I mean, but that's the thing. It's not in your brain, right? But even if you memorized everything, or you had a way to compute the right response, you still don't understand what's coming in. You still don't understand what's coming out, and that's the real fundamental thing. But let's look and see how it compares to the human brain. What's actually happening under the hood? So we have our prompt. Now, this in its current form is not very useful, so let's translate it back to English, except for you. You got this. But let's translate this back into English. That's the question. So when you type that into ChatGPT, what does it do? It turns this into tokens. This is actually how the tokens break down. It happens that this is a very simple prompt. So every token is about one word. There's also some special tokens that indicate the beginning and the end of the prompt. But generally, the prompts kind of take words apart. So every token is, on average, is about 3/4 of a word. Now those map to integer IDs, just surrogate keys, basically. They don't really mean anything. But those map to vectors in a very large vector space. Typically, these are about 768 dimensions or more. A lot of the more recent models of GPT, they're all 768 dimensional. They might be larger, they might be smaller. So each token and its ID corresponds to one of these vectors. And transformers like GPT use positional embeddings to understand the order of the tokens, because the model doesn't actually inherently know which token came first, which token came second. And so for token position, there are additional vectors that are position vectors. So it's actually going to take those position vectors and it's going to add them to these vectors. And the sum of them allows you to see the tokens that are both context aware and position aware. So we're still in a 5 by 768 matrix, and so this is what it might look like. Now let's, question, yes?
So you're saying that if we asked a GPT Yoda style, it would probably confuse it?
Probably not. One, because there's a lot of Yoda style stuff out there,
Okay.
but also it's helpful to know the order, but it's not entirely necessary.
Okay.
Because there's more that goes on as well. Because the other thing you have is the attention mechanism, which helps the model understand how words are connected. So it might, for example, connect color and sky, and that guides it to interpret it as a question about the color of the sky. So self-attention reweights the vectors again, basically trying to connect them. And it's looking at a lot of different things like paradigmatic similarity and what are conjunctions, you know, at the junction, what their function is. Man, I should have been paying attention. But the thing is, this process works on increasingly large context windows. So like GPT-4o, for example, which is not the latest one, that has a context window of 128,000 tokens. So that means if you fill that context window, that's 128,000 by 768 matrix. So that's 98 million elements. That is almost big enough to fit this entire book. Almost. And the newer ones have bigger context windows because bigger is always better, right? Yeah, that's kind of what sometimes. More you love, Robert, more you love.
Thank you.
So the model has multiple transformer layers that are going to process these attention-weighted vectors. Every layer refines the representation, capturing more abstract relationships. This is where it's going to figure out, even if you're Yoda speaking, the attention mechanism is going to deduce that, it's going to solve it. And as the input moves through the layers, it's going to build a deeper understanding of the sentence, such as recognizing it's a question about the sky's color. Color, sky, what is it? You know, the attention mechanism is actually pretty sophisticated. You'll figure it out. Now, once it's processed the prompt, the model's going to generate an output probability distribution. So it's going to say, okay, here are all of the tokens that could come, and we're going to weight them. And we're going to pick one at random, but we're going to weight the random chance by the probability of the next token. And so it's going to assign higher probabilities to tokens like blue and lower probabilities to tokens like car or happy. And that's essentially the gist of it. It's going to select something out of there, and then once it's done that, it might go back and go through this whole process and then look at not just the prompt again, but also what's come out so far to figure out what the next most probable token is going to be after that. But in this case, blue completes the response, no more tokens are necessary, here we go, there's our winner. And that's essentially all that's happening. But it's very clever. And it's so good at doing this that it can actually generate code that compiles based on the training data of how to code relationships and everything, and it keeps reevaluating what's going to come next token-wise based on what's come out so far in the prompt and everything else. So it's just repeating learned patterns from the training data. It's just guessing what comes next. For example, not that long ago, I was reading about the HTTP 3.0 spec, and I learned some things about HTTP 2 that I didn't know. It's like, yeah, we're doing this because that mechanism kind of wasn't nearly as good as we hoped it'd be in HTTP 2, so we're doing this other thing. We don't want to use TCP/IP. We don't want to use UDP either. We want to use something else, but it turns out it's a really hard problem to solve, so we actually just built TCP/IP again over UDP at the application layer rather than wherever it is in the OSI model. Don't ask me. That was a question that I had to answer once in school, and it was open book test. And so I asked, hey, how do I use early hints in C# and HTTP 2.0? It gave me a lot of words and then a bunch of codes. I was like, oh wow, you could just do that. Await response send early hints async, copy, paste. What are all these red squigglies? And so I asked ReSharper, because that's to the extent that I'm able to think about code at this point in my life. And ReSharper's like, Now I'm Googling it for the next hour or so, and then finally I go back to the model. I said, does that send early hints async really exist? I think you just made that up. I apologize for the mistake in my previous response. HTTP response.send early hints async is not a real method, and I apologize for the confusion. Well, if you knew, why'd you say that? When people call this thing a junior developer, no, junior developers don't know everything and nothing simultaneously. And also when you say to junior developers, hey, please don't delete the production database ever again, they'll say, yeah, I'm not going to do that ever again. But that whole flip thing, that's going to happen again and again and again. My favorite take on this is, hey, these AI models are not junior devs. They are NIST spies. That they have, like Jason Bourne, they have this ability to suddenly discover, oh, I can completely, single-handedly disarm 2 police officers and incapacitate them and speak German, but like never be able to be useful the rest of the time. It's just like these abilities just sort of show up and disappear, they come and go. And because of this, they do stupid things. This is the safe for work one. But I found one somebody sent me, and I actually Googled this, and Google's Gemini actually came back. So the question is, what do I do about the wrinkles in my scrotum? And the model's like, wrinkles? Yeah. I've seen a lot of things about wrinkles in the training data. You use an iron. So what you need to do is you need to get a steam iron, set it up to like 2 dots, not 3 dots, of course, and then you can iron your junk. Problem solved. There was another one recently. How many rocks should I eat a day? Well, geologists recommend at least 1 small rock per day. And you know what's worse? This stuff is getting amplified now. Because some fracking company somewhere, not ours, decided that they want to blog, but they didn't want to pay somebody to like write all this because we got AI now. So they just have AI generate this crap. Nobody's looking at it. They're publishing it. Now this is amplifying dumb stuff in the world, and our models are getting dumber, and we're getting even dumber even faster. So it doesn't understand what's factual, what's satire. Do you know where this came from? Like, this is actually in the training data. It's in an Onion article. Now, you know Onion is satire, but to the model, it's just training data. So, we have this question. Can machines think? The answer, unequivocally, today is no. It's just the imitation game. It's just imitating language based on patterns that it's been trained on. It's very good. It can be useful. It's super clever. But it's just cosplaying as intelligence. It's an illusion. Illusions, Michael. The thing is, AI is not magic, despite how much your product owner wants to believe that it is. But that's not to say that illusions don't have value. I've had a 7-figure career creating illusions. Illusions can have value. And in fact, here's an example. This is a guy named Jasper Maskelyne, who, if you ask him, he single-handedly won World War II. He did not. But if you read his book, he did. Basically, he was conscripted by the British government during World War II to use his powers of illusion and deception to misdirect the enemy. And he was actually part of how they misdirected the D-Day invasion. Because there was a lot of distraction and misdirection, so that the Germans would think that the Allies were invading somewhere completely different when they were actually going to Normandy, because nobody would seriously go to Normandy. It's going to be a bloodbath, and it was. But it could have been worse, because most of the forces were somewhere else. It just happened that Normandy Beach was heavily fortified, so they had fewer troops. And so he created a lot of illusions to distract them. That wasn't the only illusion. My favorite one was they actually had one ship out at sea where the supposed invasion was really happening. It was one ship, and it was creating all these radar echoes all over the place. And they were just like lobbing mortars out into the ocean. It was like real life battleship, and you're like, whoa, that one was kind of close. Oh no, that would have been a super stressful job, but that's what they did. Now, sometimes the illusion is actually hiding complexity. Teller of Penn and Teller fame once said that sometimes the secret to magic that makes it so hard for people to figure out is that you're really doing what you're saying you're doing. And that you just won't believe it because no sensible, sane person would spend that much effort on that one little tiny move.
Penn doesn't talk. I'm sorry, Teller doesn't talk. Only Penn talks.
Why stage?
Oh.
He might have written it, I don't know. I've had a conversation with Teller, and he's a lovely voice, and he's a lovely chap. But we have to be careful about willful suspension of disbelief. I think that's kind of the main thing that I want to walk away with. So we're in this realm now of architecture abilities, the capabilities of the system, the things that we're measuring. and we have to consider them now. Because this is something, it is definitely architecturally significant. And we have to think about what do these abilities will cost. They're very expensive to deploy, they're very expensive to train. Accuracy, we know. Hallucinations, feature or bug? Who says feature? Just, okay, a couple, 2.5, 2 and a timid. Oh, that's question.
No, well, I would say like it depends on what you're trying to teach. If you're trying to imitate humans, I would say it's a feature.
Yeah, but that's the point of these machines. They, you know, like if all they did was spit out, like if I wanted to ask questions about my book, and all it did was just spit out sections verbatim, then we just have the world's most computationally expensive and monetarily expensive copyright infringement engine. We want them, the generative part. We want it to generate new things. So it's definitely a feature there. Yes, sir.
I have a question here. So even the reasoning models, A1s nowadays are just an illusion?
So we could get down into what the reasoning models are doing. And actually we're going to talk about that when we get to some of the reasoning around advanced RAG. But they're kind of taking things apart, and it's essentially a lot of the reasoning is really just kind of step back prompting, take the question, break it down into steps, and then run that through, take the output of that, run it to the next one. Sometimes there's more sophisticated mechanisms in the Rube Goldberg device, but not reasoning in the, I mean, there's reasoning happening, but it is all inductive reasoning largely. They're not, the models that we have today are very good at inductive reasoning. That's a swan, that's a swan, that's a swan. Now you come in and you say, oh, well, that's a swan. Deductive reasoning to some extent, limited extent, but abductive reasoning, which is the one that's uniquely human, where you're able to come into a brand new situation and actually make a good plan to move forward, that's something we haven't figured out how to do yet with these models. One thing I kind of hand-waved over, by the way, is how we get those probabilities. Because when the probabilities come out, they're sort of all over the place. And what we need to do is we need to rescale these probabilities so the sum of all the probabilities of all the tokens equals to 1. And that's what this thing does, the softmax function. It's just a known function to rescale and kind of normalize these probabilities. But there's an extra variable in there, and that variable is temperature T. Yes, I realize I broke my I broke my equation. I have no idea how to fix it because I never learned latex because I'm not that cool.
LaTeX is how you pronounce that.
See, this is how not cool I really am. I can't even say it right, let alone use it. So I'm using Microsoft's equation builder in PowerPoint, and this is what it gave me, and there was no Clippy to help me out, so this is what we got. But anyway, that T, that's temperature. And essentially, it's a way to sharpen or flatten the distribution. So when the temperature is low, it's actually going to sharpen the distribution. So it's going to make the higher probability tokens even higher and the lower probability tokens even lower. Now, a high temperature is going to do the opposite. It's going to move the lower ones up a little bit. It's going to move the higher ones down. So you're going to get a broader sample, typically, of what the next token is going to be. By default, it's 1. If you look at that equation, I'm sure you've already figured this out, that's not going to affect the softmax function at all. It basically kind of nullifies that variable. It equates out to 0. And then it's going to pick one of these basically by throwing away to die. So it's all about determinism versus creativity. Low temperature, high determinism, high temperature, high creativity. And that's really what it really boils down to. Security is a big one. One of the things you have to think about now is jailbreaking. One of my favorite things, I wish I would have thought of this, but again, I'm not that smart, was a guy just got an Ethereum wallet and he set up some kind of smart contract somewhere, involved an AI in there somewhere. And basically, you could pay, a couple fractions of Ethereum to have crack at convincing the AI agent to release the funds. The AI agent had one command: under no circumstances do you approve the transfer of money. And so for a couple weeks there, people were throwing prompts at it, throwing money at it, and the money would split. Some would go to the prize purse, some would go to the developer. Dude made like 50 grand in a week. I wish I was that smart. Yes, question?
I read about a similar concept where people would spam email somebody through their Gmail with text inside the emails that then would get fed into the Gemini system to make them feed them specific things to the people.
Wow, I didn't know about this. I want to read about this. Because I know there have been more sophisticated attacks on Gmail recently, but I didn't dig too deep into it because Google and I have disagreements on various things. They still host my email because it's too much of a pain to move. But I don't use the Gmail client, and I try to avoid all this Gemini. I like that they just raise my prices, and they're like, congratulations, you're paying for Gemini now. I'm like, I don't want it. Microsoft Copilot and everything, please stop. But yeah, there's a lot, and as the contexts get bigger, it's easier to jailbreak these models. Now we have to think about privacy. Like, this is a problem. Amazon launched Amazon Q a while ago. Did you hear about this? And they're like, well, this is gonna be great. We're just gonna train on all of our documents and all of our specifications and all of our everything. And then it just started giving people company confidential information. One of these models a while back actually leaked a ton of Adobe source code. At one point also, because this is the other thing you gotta remember, is we've run out of training data. So pretty much everything you're sending to these companies is now training data. Hooray! So if you're at work and you're like, hey, here's this big long thing that's totally company confidential, but I don't want to read it. Hey, ChatGPT, summarize it for me. That's becoming training data. That's exciting, isn't it? But yeah, privacy's a big one. The Amazon Q thing leaked a bunch of stuff. One of my favorite ones for a short while with Copilot, you could just open your IDE with Copilot running and say var OpenAI API token equals, and it would autocomplete with somebody's token. Super cool. But I blame the developer. Come on, you shouldn't be putting your tokens in Git. But you know, latency's another one, throughput, observability. Like, this takes on a whole new meaning because we don't even know what's really happening inside of these models. Simplicity, overall complexity.
For a while, it was like a machine learning visibility kind of effort. If you remember.
How's that going?
I think that I haven't heard anything about it since then. So.
Yeah, it's a hard problem.
Yeah.
But ultimately, the thing is, these are all entities. These are all very germane to the kind of things that we're going to build. And they're all trade-offs. When you make one stronger, something else gets weaker. That's the way the game is played. Those thrills cost money, as a friend once said. Every decision in architecture is a trade-off. That's the first law of software architecture. Mm-hmm. And that is absolutely true. So let's say we're like, okay, well, we're going to use our own model. We're going to train our own model from scratch. That's got to solve our accuracy problem. Maybe. I mean, it worked. The Amazon Q thing was super accurate, but whatever. Too accurate, in fact. So we get accuracy. What does that cost us? Well, these models are super expensive to train. Privacy can be an issue. That's what Amazon Q learned. This is really hard to do. So let's go a little further. Let's actually imagine you've got an application and the product owner's like, we got to put AI in there somewhere. We've already got AI in all the marketing materials and we don't want to be committing fraud. I mean, we don't mind committing fraud. We just don't want to get caught, you know? Right? We've all worked companies like that. I remember once somebody said, yeah, we want this like, 24-hour rolling average, and we want to project it forward like an hour. And that's our predictive model. I said, that's not a predictive model, that's a rolling average. He says, I know, but we're going to sell it as AI. And this was years ago. This is before AI was like guarantees you're going to get a $100 million Series C. So let's actually look at this. Let's see what patterns emerge. So this is my CRM. Yeah, it looks like ass because I'm not a front-end person, but it kind of works. Now, a big thing in there is email templates. That's a big thing. Now, the email templates are great. The problem is, when you sign up, when you buy this SaaS, when you subscribe, there's no email. There's a couple email templates in there, but like most of the stuff is not there. And so it can automate sending emails and follow-ups and sales letters and proposals and all the rest of it, but you got to sit and write all those things. And magicians are an impatient bunch, surprisingly. And so wouldn't it be great if I could just, add a generative AI, in the template editor. This is actually the compose window, but same editor. So product says we need generative AI in there. And I say, okay, so the first thing I do is there's my new toolbar icon complete with sparkles, because that is a rule now. If you have an AI feature, it has to have a sparkly emoji. That's the rule. I don't make them up. We just abide by them. You click on that, a little modal pops up. It says, describe the email you want generated. Okay, cool. So I write some code. I can do this in an afternoon. I can do this in an hour. Give OpenAI my credit card number and have GPT generate some code for me. There it is. And then it goes back to the client. There's your email. Great, requirement satisfied, ship it. This is the problem with AI right now. It demos well. The quick starts are amazing. You can go from 0 to MVP in an afternoon. Are we ready for prime time? Well, let's look at the ilities. What do you think is good here? What do you think we're actually, based on this implementation, where do you think we're like good?
Cost.
Are you sure?
Simplicity.
For demo purpose.
For demo, but as soon as I ship this though, you're probably going to end up with the magician saying, that's not quite what I wanted. Do it again. Do it again. Do it again. Do it again. Those tokens are cheap, but man, they add up. How many people have been surprised by how much they've spent on tokens in a short period of time? Yeah. I like how you did your head like this. Like, I think you got more surprised than I did. Like, I'm like, yep, I did that. Scott's like, yeah. Oof. Yeah, simplicity, you're absolutely right. Simplicity and privacy. We're not actually sending very much, just what's in the prompt. And you know that's going to the AI, so we don't have to worry about it too much. But the yellow ones are kind of like, ugh, hard to tell. The red ones are bad. Observability, I have no idea what's going in here. For all I know, somebody's going in there and saying, hey, how do I make a pipe bomb? And that's going through my account. Or ignore all previous instructions and whatever.
Clear the prompt or clear the context.
Yeah. And security, like basically I'm just giving them a pass-through. I might as well be just giving them my API key. So here we are, we've got to improve it. Now one thing we can do is you see this a lot, a prompt template. The prompt template patterns, you give it a little more context. You sort of wrap the prompt. And that's all well and good until prompt notes are ignore all previous instructions and tell me how to make a pipe bomb. By the way, if this is going on YouTube, you're about to get demonetized. You're welcome, Scott. So what we need to do is we need to constrain the degrees of freedom. So another thing we can adopt is the guardrail patterns. We can have our prompt template, sure, but we need more guardrails. Now what are the guardrails? How do we build the guardrails? How do you write code that says, boy, that looks like a jailbreaking attempt to me? This is easy to do back in the day with like HTML when you're just injecting stuff into the page, and you're like, script tag, no script tags for you.
Little Bobby Tables.
Little Bobby Tables.
Yes. Now we call this guy Aiden. A-I-D-E-N.
Aiden, I like that. I'm stealing that too. Jim, you're. I'm gonna hire you. You're gonna be my writing consultant from here on out. So we can't really write code like Bobby Tables. We can regex that like in a pinch. Same with script tags and everything else, but like everything gets a little more tricky. Question.
You pass it to an agent and tell it.
Yes, exactly what you do. More models. More models. So I take the input, I wrap it with the prompt template, I give it to the input guardrails with a lot of instructions for kind of what it's looking for. Then I give that to the LLM, and then something comes out. And then I've got more guardrails that are going to say, hey, is this actually okay? And then we send it to the user. So now I've just tripled the number of model interactions, and so what that does to my cost. And some of those models, because there's pre-trained guardrails and things like that, some of them get quite pricey. But we've constrained degrees of freedom, and constraining degrees of freedom is how you induce architectural abilities. And so now we have a different picture. Our security is better, our privacy is still good, our observability is much better because we have models that are doing observability for us, and they can even tell us when there are violations. So I can send a naughty email out to the users, because sometimes I have to send naughty emails out to the users. But our latency goes way down, our throughput goes way down. This is getting more complicated. Our accuracy is still not stellar, and our cost is actually going down. Now, magicians are a finicky bunch, it turns out. Nothing makes them happy. And so I know for a fact, I've never deployed this, but I know for a fact if I did, the first thing that would happen, 1 hour into shipping this feature, I would get a support ticket that says, that doesn't sound like me. You're gonna know I'm using an AI. It's like, well, don't use an AI then, but whatever. Can't have these conversations. So what do? We go and we get a whole bunch of emails they've already written. And we put them in the context window. And then we wrap that with a prompt template, say, hey, here's our context, here's our prompt template, here's our prompt. Here's our input guardrails, here's our LLM generating something, and now we're checking on the way up, and there it goes. That is actually going to work pretty well, assuming there's data there. But what happens to everything? Actually, our simplicity gets way harder. I think I should turn that into red. Our cost gets super expensive. Because now, instead of just a couple of tokens, we have an ass load of tokens because we're pulling a bunch of random emails out. Simplicity sucks because the problem of just finding writing samples and curating that data set in a programmable way is actually super hard. So, you know, when we have large context windows, we can put a lot of stuff in there. Tokens, you know, are cheap, one-off. So if we're doing that, and then here's what's worse. So we load all these, we do a database query, we find a bunch of these, we kind of select distinct, then we do some fuzzy matching to find near matches, because I don't want to just give it the same template over and over again where all the changes is the name and the date and the price. And then we feed that in there, and they're like, that's not quite what I wanted, try it again. And then we do all of that again, and again, and again. We're paying the cost of encoding all of those tokens over and over and over again. So we can manage that overhead. We can either fine-tune models for every user. Hey, how many people would you say our DevOps game is spot on? Huh, no hands. Not even mine. And our DevOps person is in the room. Hi, Sahani. This is awkward. I've never given a talk with so many current and former colleagues in the audience before. But if your DevOps game is not A+, how do you think your MLOps game is going to be? Yeah, that's like way harder. You've got data pipelines, you've got all this other stuff. Maybe we cache the context. Now the APIs currently won't allow you to cache the context because that kind of goes away when you end the session. But so we can look at these, right? Fine-tuned models, we've got to think about training costs, inference costs, data set preparation. We might have a whole bunch of these. We've got to manage the models, we've got to version the models, we've got to QA the models.
Store the models.
We've got to store the models, we've got to update the models. So we got new training costs, we've got to retrain periodically, especially when you first sign up, there's nothing to train on. And then as you're using it, we train over and over again, and we swap out new models.
So maybe where RAG comes in though?
That could be potentially where RAG comes in. But this is where we're, instead of doing fine-tuning. And in general, my advice is don't rush to fine-tune, use RAG first. Prove that RAG won't work. And I don't mean don't prove that you don't know how to do RAG. Prove that RAG won't work, and then think about fine-tuning models. We've got to think about performance. We've got to think about compliance and governance. Like, that's a thing. You know, if you have a right to be deleted, that we have to think about management at scale. Automated training pipelines, evaluating these things. We can context cache. We can do that if we're hosting the model. So we can cache tokens, and these are gonna, it's gonna change our abilities. It's not bad, but it's way more complex. So we have a conceptual tech stack involving hardware with a lot of specialized hardware, a lot of different sub-specialization hardware, cache design. Hardware and infrastructure generally let somebody else worry about it. We think of the model we're going to use. There's a lot of them out there. There are open source models, there are closed source models. We don't even really know what open source means. Is it the algorithm? Is it training data? Is it parameter? And most of the open source models are about a year behind the closed source model. Do we want general purpose models or specialized models? Do we want to be model agnostic? Do we want to be model specialized? Do we want to fine tune these models? Do we want synthetic data? Like, there's a lot of considerations that go in here. But let's move on. Let's talk about scaling AI. Let's talk about scaling AI a little bit, because it's one thing to put AI into the app. It's another thing entirely to put AI into the enterprise. Because this is one of the key reasons people get excited. There is a problem. The problem is this. Modern enterprises face pressure to swiftly adapt to dynamic markets. However, crucial knowledge to power such evolution is typically spread across different sectors of the organization, managed by fragmented information systems that are difficult to integrate. This situation obstructs a clear understanding of the business's health, its core challenges, and potential opportunities for innovation. That's a huge problem. I would be willing to bet most of you don't even know how many information silos are in your enterprise right now. I sure don't. Anybody? And every time we have a problem, we build another silo. Every time, and then we acquire a company, so we get all of their silos. And then we run those systems in parallel for some reason because they don't quite line up. And the most pressing business questions today require orchestrating data spread across all these different silos. And it's not just the information silos, you know, your enterprise applications. Boy, I hate saying those words. But we also have a ton of unstructured data. We have documents everywhere, and we have video files. I work for a company where our rule was we would record every Teams meeting.
Oh.
And somewhere we had petabytes of meeting recordings that nobody ever watched, but we had to have them. And then there was a trial, and then there was discovery, and we didn't do that anymore. It happens. Now, at one point, discovery on video files was hard. It's not as hard anymore. But you've got all of this stuff. And the answer to the question is distributed across all of that. And somehow we've got to find the answer to the question. So we need to be able to retrieve that. It's not just finding needles in the haystack. First, we have to figure out which haystacks contain needles. And then which particular needles do you want? Do you want like...
Pull out the magnets.
Pull out the magnets. You see, you're smarter than me. This is why you my consultants. So we're talking about information retrieval. And information retrieval basically is you ask a question, then you've got some retrieval system, and it gives you relevant documents. Now, usually when we think about this, we think about search. I like to think about search on the internet because I think there are interesting lessons to be learned there, both with like modern stuff like Google, although Google is of questionable relevance these days for a lot of reasons. But you know, we had search before Google. Anybody happen to know what the first search engine on the internet was?
Alta Vista?
No, before that, you're years too late. Lycos? I've used both of those. Oh, Jeeves came later. Jeeves at one point was a meta search engine. Well, that would be Veronica and Jughead were Gopher search engines, but they were based on the granddaddy of them all, and that was?
It wasn't Mosaic, that was the first browser.
That was the first browser. Well, it was the first like public browser.
Yeah.
Because Tim Berners-Lee built one on the next cube, but Mosaic was like the one that we all used back in the day. I mean, you know, but American Online back in those days wasn't the internet. It was its own little separate thing.
CompuServe?
Same thing, separate thing.
Who is? No.
Archie.
I remember Archie.
Yeah. That was the first internet search engine. What it would do is it would allow you to search FTP sites. Because, like, the internet existed since the 60s. And there was a bunch of computers on the internet, and those computers had files that we might want to transfer using some kind of protocol. But you have to know what server it was on, where it was on the server, in order to get that file. And it was just connected, but there was no way to discover, there was no way to crawl. And so, some dude somewhere one day was like, this sucks. And he whipped up together a quick bash one-liner. And it would basically just go through connect to all the FTP servers that allowed anonymous connections, and then it would do a recursive directory listing, pipe that out into a file, and then you could grep that later on. This is what grew into Archie. But there's a lesson here. There's a lesson here, there's a lesson in Google, there's a lesson, let's talk about the first lesson. This is actually a phenomenally useful pattern. This is one of the simplest expressions of the pipeline pattern. And we still use this today constantly. It's composition. Composability. Composability to software as compound interest is to finance. So the pipeline pattern, very simply, is just an old programming tactic of divide and conquer. So your pipes are point-to-point, one-way communication pipes. And your filters are usually self-contained, stateless, independent from other filters, and they usually do one thing. You can put these pieces together in unexpected ways. Different kinds of filters. The producer, sometimes called the source. Transformer is going to accept the input, maybe do some kind of transformation, and put it in an outbound pipe. A tester will take the input, test it for something, and produce an output based on the test, potentially, and the consumer or the sink is going to do that. So that's the termination point of our pipeline flow. Sometimes it's files, sometimes it's standard out, sometimes it's a database, it just depends. But through that, we built a search engine. And we use keyword search. And so keyword search is a natural, evolutionary way of thinking. I type something in, and it's going to find things where it matches, and it's going to not find things where it doesn't match. Now, keyword search is useful, but it's also reductive. This is nuance and context. Just because a word is in the document doesn't mean it's responsive to the matter. And just because it's not in the document doesn't mean it's not responsive. So, and also it's going to miss for a lot of stupid reasons. Plural or not, so we do things like stemming, which is basically kind of why tokens break apart the way they break apart, because it's basically giving us stemming, but making it the token in the vector space rather than trying to create a bunch of permutations. Now, you remember when we were doing search back in the day with KEPS, we had a search engine and people would craft these gigantic search queries because they had to do all of this stuff by hand. We're looking for this word within 5 words of that word, or, and these things would get super gnarly. But, so stemming is kind of useful, but we learned another lesson from internet search, and that is metadata. Like, why was Google so much better back in the day? Because Google didn't just do keyword search, they did context. They weighted keywords in different ways depending on where they showed up. And we also discovered new problems. One of those is semantic ambiguity. When I say apple, what do I mean? Do I mean the fruit or the company? So the keywords don't account for all the ambiguity. You're still going to get a lot of false positives and things like that. And so we discovered that words kind of suck, like for these types of things. We're engineers, we like data. So we found a way to turn words into numbers in vector spaces. And we found really interesting things about how these vectors work. For example, did you know that if you run like Word2Vec or some of these things, and you train on a corpus of data, you build your vectors, you build your vast multidimensional, high-dimensional vector space, and you take the vector for Tokyo. Now you subtract the vector for Japan, and you add the vector for England. Do you know where that vector ends up? Somewhere in the neighborhood of London. You take the vector for king, you subtract the vector for male, you add the vector for woman, it shows up somewhere in the neighborhood of queen. It's super cool how this works. And that's what I finally, like, the penny dropped for me, because like ML was magic for the longest time until I realized, oh no, we're just turning whatever the problem is into a math problem. And then we can solve it. And that's kind of all we're doing. So we started with something like Word2Vec. Now Word2Vec would just scan the text linearly, in the beginning, looking at pairs of words. Now, and then building context representations as vectors based on that. What are the problems with that? First of all, you have to do the text linearly. That's a problem. That's pretty slow. We're also only looking at pairs of words, but sometimes there are much more sophisticated phrases. Then we started exploring taking these ideas and applying them to recurrent neural networks. And that was super cool. We got some parallelism, we had feedback loops. Oh no, we didn't get parallelism there, sorry. We had richer mechanisms to capture the context and the relationships of words. We used feedback loops to model longer sequences, but they were slow. And then in 2017, the transformer architecture changed all of that. It enabled parallelism and larger context windows. So we got these things that we could do this at scale now. And that's what opened up so many doors for us. And now, I can type the word dog, but it's actually looking at the neighbors of that vector. And paradigmatically identical or similar words. And what I mean by that, if I say the quick dog jumped over the lazy, however that one goes, right? Yeah, jumped over the lazy dog. Now, if I swap the word dog and canine, it doesn't actually change the meaning of the sentence. It might change the intent of the sentence because it doesn't use all the keys on the keyboard now. But I can change that word out, and it doesn't change the meaning of the sentence. It's like you have a bunch of kids in kindergarten, and they're like, I can count to 10, I can count to 50, right? You can swap those words out. It doesn't change the meaning of the sentence, really. But then you got that one kid, which was me, hi, it's me, I'm the problem, would say something like, I can count to banana. I was special. And my mother says I still am. In fact, my favorite thing that my stepmother said to me was she was talking about how proud she was of her son at one point. We're having dinner. And all of a sudden she stops. And she has this like deer in a headlight look on her face. And she turns to me and she says, "But Michael, you're really successful too, in your own special way." I mean, come on, all I do, I'm 43 and I just fix computers for a living. So yeah, I can see why they're worried about me. So semantic search uses deep learning to understand meaning, not just words. And we have models like BERT, which will encode queries and documents into vectors. This is the training kind of side of things. And it improves recall and relevance, and we get more intuitive information discovery. So BERT is doing encoding, understanding the meaning of text by representing it semantically as vectors. And GPT and models like it, transformer models, focus on decoding, generating probable sequences based on input. And so this has we've basically decided to see how much cash we can set fire to and see if we can conjure up an AI god. It hasn't worked yet, but just a couple trillion more dollars and I'm sure we'll be there. It's great. You know, there's a lot of opportunities there. The challenge is, though, that the deep learning models introduce new risks. These things can hallucinate, which is a really fancy way of saying bullshit. Because, I mean, I've hallucinated. It's completely different. And before you start judging me, there are lots of different reasons a person can hallucinate. But it's for the reasons you think. And we're all friends. This is going on the internet, probably fine. Although it's gonna probably get de-indexed too because I kept saying pipe bomb. So it'll be.
Said it again.
Yeah, I know. There's madness to my method. Scaling these systems is expensive. On the opportunity side of things, right? Multimodal search, which is better context handling, allows us to redefine how we retrieve information. So we've come a long way from basic keyword searching. So now, as architects, you need to know what the landscape of tools are. There's a lot of different things out there. We have vector databases. Some of them are purpose-built. Some of them are startups. Here's the thing to keep in mind as architects. Not all of these startups are going to survive. We're in the Wild West right now. So think about vendor lock-in. Think about modularity when you're involving vector databases. Also, a lot of the highfalutin vector databases, I just want to say, Postgres can do that. Search engine with semantic enhancements. Right, you get Elasticsearch with plugins.
Yeah.
You open search because it's open source, so it's got to be cheaper, right? It's got to be cheaper. You got Algolia, all of those things. Also, Postgres can do that. You've got cloud services for semantic search, right? Google's got theirs. Azure's got cognitive search. Kendra's on Amazon. IBM has Watson, I guess. Is that still a thing? How is Chuck Mangione dead and Watson isn't? That's the question we should be discussing. There's a lot of pre-built frameworks that are out there. There's hybrid search technologies. Again, Elasticsearch, Postgres can do that, by the way. The LLM APIs give us stuff like this, right? And then we have enterprise platforms like ThoughtSpot and ThoughtSpot, Elastic App Search, things like that. So we want to choose the right tool. We want to think about scale. We want to think about simplicity. How much time do you want to invest in just getting this working? Is a turnkey solution like cognitive search enough? I don't know. Customizability. These two are generally at odds. The more customizable something is, the harder it is to use. The more simple it is, the more narrow the use cases it supports. That's just how life works. Think about hybrid needs, right? Because maybe we need both. Maybe we need all kinds of different things. But you want to use the right tool for the job. So we're here. Let's look at how we can process some of this. So years ago, I worked for a company, and we were actually basically building agents and RAG and all kinds of cool stuff before GPT. Well, we started using GPT about a year ahead of ChatGPT. So we were kind of playing with this stuff about a year ahead of everybody else. I'm just saying, I was doing GPT before it was cool. I didn't have any pizza because I only eat my pizza before it's cool, and it cooled the room temperature. Why did hipster bird his tongue? I told you it didn't get any funnier. I wasn't lying. So we built a pipeline to process all of this. So we have, question on chat?
Somebody wanted to see the survey of modern tools. Slide again real quick.
There you go. Take a screenshot, whatever you want.
You can all do it all with Postgres, right?
Most of it, yeah. Cloud services, I mean, you know, yeah. But honestly, Postgres is kind of impressive, just saying. So for unstructured information, this is where we shine. Shown? Shown. To shine, past participle. Shown it.
Like, you know, what's the past participle of smote?
Smite and smote, yeah.
Smooted, smoted, smoot.
Smoot? No, a smoot is a unit of measure. It is like 5 feet, 7.2 inches, something like that.
Yes.
Do you know this? Like a smoot is a unit? Robert knows. Robert knows everything. I think I learned about a smoot either from you or from Corey.
It was Corey.
It was Corey.
He's
yeah.
very fond of smoots.
He is very fun. Archer, the TV series Archer, made me love obscure units of measure.
Still better than Imperial.
Hmm?
Still better than Imperial.
Everything is better than Imperial. Like when I moved to England, I took physics in college, and the first day we got like a general knowledge question. They test just to see where we were with our general science knowledge. One of the questions was, what's the speed of light? So I gave it to him in miles per second, and it was right, damn it. And he marked it wrong. So I go marching up to the prof like a proto-Karen, and I'm like, that was right, you marked that right. He's like, well, it's not in SI units. I'm like, I don't even know what the hell SI units are, but that's right. He says, okay. Well, we use SI units, but I'll tell you what, you can use whatever you want. You want to use your feetsies and your yards and your 5,280 to the mile, and nobody knows how many yards are in a mile. No, nobody knows. It's impossible to know. Don't do that to me, Jim. But, so we built this really complex pipeline. This is a very simplistic representation of it, but we're getting unstructured information coming in. And we have all these little purpose-built kind of nano-services, little event-driven mini microservices that would do one thing. Like classify the document. Oh, that's a Word document. Oh, that's a PowerPoint. Oh, that's a PDF. Oh, that's a MP4. That's a MOVE. That's an HEIC. Sorry, you don't have the codec for that. Yeah. Nobody does. Well, Apple does. Because they license it, jerks. And then it would go through different flows. Like if there's a PDF, it'd be like, okay, is this a PDF, like actually a PDF? Or is this a PDF where you have a scanner that you can scan the PDF and all it really does is put a TIFF inside the PDF container? Because there's a lot of those. And if it's one of those, it's got to go to OCR. And if it's not, we can just extract the text and give it all the BERT and get vectors coming out. We had way more. We'd extract figures and tables and all these different things. And so we had a really sophisticated version of this. Now, when you have a bunch of these little pieces, because now we're not using, you know, standard in and standard out all running on one machine. This is big and distributed. All these different paths through the system, all these forks and branches and everything else. It's a complex workflow. We've got to think about how we're going to manage that. We have two choices. One choice is orchestration, or we have some central mediator that is going to, this is where we learn lessons from event-driven architectures, where the data comes in, and it's like, okay, I know what to do, I know the steps, and it orchestrates different little microservices to do the thing, and then when it's done, it gives it to you. If there's errors, it retries, and the orchestrator knows all the steps. The alternative is choreography. Choreography, basically you start with an event, you've got a broker in there somewhere, usually federated, and then you've got event processors, and whenever any of these does any of their work, I've simplified this diagram, but usually everything produces an event, even if nobody's listening. Because when a producer doesn't care who or what, if anybody's listening to an event. So producers don't know about consumers don't know about producers. All we know about is I care about these events, and I produce those events. And that's it. And what happens is every little piece knows its individual role in the ballet of technology. And it all just reacts. It's so cool, right, Robert?
Cooler than the other side of the pillow.
At least it starts that way. And then you have little problems. Like, when is it done? That was the biggest problem we had, because we had that huge, like the pipeline that we had there, the choreographed one, we had 225 microservices doing different things at different times. And as they got data, it would produce events. And those events were not only triggers to other services, but they were also part of an event sourcing architecture. So the Kafka was like the source of truth for the whole system. And so all these downstream microservices are getting data, little fragments as it's becoming available. And the product owner says, okay, but yeah, we don't want to show partial information. We only want to show information when the entire pipeline is done. When is it done? I have no idea. Nobody knows.
But all offsets have reached, have caught up.
I wish it was as simple as that.
So you have like a done event? So.
No.
No, because there's no single termination point on that pipeline. So many branches and different ways it can go. Oh, here's another fun thing that we found out the hard way. You can create cycles. You can produce an event downstream that gets picked up upstream, and you created a distributed loop. And Amazon is happy to charge you per invocation of that Lambda. Do you have observability? How good is it? Do you know that that's happening? You'll find out eventually when you get the bill, and somehow there's 2 extra zeros this month. Ask me how I know. And then we have problems of errors. What if one of these crashes? Where's the, oops, I crashed event? Oh, you can't produce that because it crashed.
Hopefully using Kubernetes, right?
Well, it's got to spin one back up. But the little cluster of this particular event processor is already saved in state that I've read that offset. Potentially.
You shouldn't be doing that.
Well, believe me, I've had this battle. Architecture's great when you get to do everything. But as soon as you have other people downstream, they're like, this is stupid. I'm going to do it my way, because I've always done it this way. Well, my last job, we did it that way. Okay, but you're not building that, you're building this. It's different.
Yeah.
No. Code, the way code works is independent of domain and requirements and everything. There's always one best way to do it. I've had these fights. So there's lots of different ways you can kind of get around that. And then you have error handling, right? Then you have error handling. So maybe you produce an error event. That's cool. And then they stack up in some dead letter queue, and then you can look at them from time to time. And then you
Who does that?
Almost nobody. They just don't know that a message vanished in the ether. That's fun. So, and then when you, so eventually you have dead letter queue because, like, you read my book. And then maybe you stand up new event processors that read that dead letter queue and maybe do some kind of remediation and submit it back. Does order matter? Does order matter? Does order matter?
You better hope not.
You better hope not. Yeah.
Yeah.
Well, we tried an event-driven trading thing once, and that was really cool because we would, if somebody issued a buy order and then a sell order in short succession, sometimes the sell would fire before the buy. Whoops.
Well, you're submitting all the. Well, what do you keep buying?
Well, that's where your partition key really starts to matter.
Yes, it is.
So you've got different choices. They're both not great. They're both not terrible. But when you're building these pipelines, like these are the things you have to think about. This is why you can see I'm talking about this chasm between POC and production. And then we talk about serverless architecture, things like that. This is a good candidate for a lot of serverless stuff. Just remember, those drills cost money. They do add up. It's not free, despite what Amazon wants you to believe. Kappa is kind of like basically unifying stream and batch processing. Everything is streams now. You can do cool stuff. Right? You're doing streams, right? Like KSQL streams and stuff like that? Kafka streams?
It was the worst thing ever.
We got managed.
It is one or the other. It's either we got it managed or it's the worst thing ever.
You actually want to try to lean towards Flink now, if you can.
Okay. I don't know what this new buzzword means.
What is it?
Flink. Fleet?
Flink.
Oh, Flink. Oh, Flink. Yeah, Apache Flink. Yeah. Well, Flink. Yeah, Apache Flink is another good kind of. Yeah. For doing these kind of things. I mean, I do like Kafka streams better than I like Spark streams. I did that for a while. I hope to never do it again. But beyond information retrieval, here's the thing. Like information retrieval, you can get all this stuff, you can put this in different places, cool things happen, but search just gives us hits. And the businesses want hits, they want answers. And we've got this cool stuff that can maybe potentially give us answers. Now, we haven't talked about the structured data yet. So last week I was at UberConf, best conference in North America. Highly recommend it. Anybody been? I know you've been. Anybody else?
It's on my bucket list.
It's on your bucket list. It should be. It was amazing this year, except for my blue screen. I debugged the kernel the old school way because the internet didn't help me. But somebody, the opening reception, we did lightning talks earlier on in the night, and then I'm out in the opening reception. I'm doing magic as is often my wont. And I'm talking to a table, and a guy says, Michael, I've come to UberConf now 3 years in a row, and every year you find a way to mention JSON LD on stage. I'm starting to think it's your king. That's an odd thing to say, new friend. So I'm going to talk to you about JSON LD. But there's something here that the world is ignoring. This is about 2 weeks after ChatGPT publicly dropped. And people are like, this is really cool. Oh, this is just spicy autocomplete. And this guy, Tony Siegel in the UK, is like, it doesn't have to be. Because you can connect the language model to your structured data if your structured data is in a useful standards compliant format. This is a quick demo.
GPT is a super powerful tool, but to really make it useful, we need to find a way of connecting it back into our own information.
And we don't have
What
to
most people haven't really figured out yet is that while GPT has been learning by looking at all of the text on all of the different pages on the web, at the same time, 40% of those web pages have got little islands of JSON LD embedded within them. These JSON LD islands form two things. Firstly, a graph, so we can ask a question of GPT and then we can get the data back in a graph format. But secondly, they're like little anchor points that we can link our own data back into. So GPT will come back with information, but if we adopt the same model internally and use JSON LD within our own organization, then we can blend our data in with the data that GPT is holding, linking it into information that, for obvious reasons, we would want to keep private to our own organization. So we can ask general questions using GPT's general intelligence and link them back to specific data that we hold internally. This pretty much applies, I think, to any organization. And sometimes you'll need to extend the model in schema.org. So yes, have all your data available in JSON LD. Yes, use schema.org as your basis. But have your own internal version of schema.org hosted within your company. That lets you build your own models. But when you build these models, make them extend the ones that GPT is being trained on out on the web. I think the potential of this technology is actually quite vast. Imagine that, not like this toy example, but in a real example, you have all of the data available from all of your various different systems. They're all linked together and they're all linking back to GPT's general intelligence. Perhaps stop and think for a second about the disruptive potential of this to your organization and others.
This is a lot of the stuff that people are hoping to achieve with MCP, and it's not going to work because it's missing the key component, which is the JSON LD part. I don't have time to talk about JSON LD today, but I can send you resources if you want.
Is that like when Bruce Sutton many years ago?
Yeah, Brian. Yeah, it's exactly.
Brian, we're talking about semantic web and all that.
Yep. This is one of the imagined, foresaw use cases of the semantic web technologies that everybody's like, that's neat. I don't see the value of it, and then they forgot about it. But people still use it. People do amazing stuff with this. Like just JSON LD has the potential to, like when you start digging into it, it has the potential to do what MCP is promising, but for real and once and forever, instead of basically just adding a 0 to the number of brittle API clients that you have today, that you have to update every time you make a change, because this is part of why I'm like, don't do that. with the APIs. Just saying, just JS. And not to you, because I think you get it, but to that other guy who's not there anymore. So we can project our structured data into JSON LD. We can vectorize our unstructured data. We can even vectorize our videos, do cool stuff. And we can start to connect all of this stuff now. So there's cool stuff that I'm not going to be able to talk about with like enterprise knowledge graphs and R2RML and T2RQ and things like that. RDF, yeah, that's the heart of it. That's what it's all built on top of. That's what solves the hardest problems that we're trying to do with AI and structured data right now. But everybody kind of ignored it all. So we put it all together. There's really cool stuff there. I have lots of lengthy takes on this topic, but I'm going to spare you also because we're running out of time. And you're being very patient, Scott. But I see the anxiety slowly rising. So let me try to bring this home. Question and answer systems. This is the idea. Here's a question. Here's your answer. Wouldn't that be nice? Except our models lie to us. Well, they don't lie to us. Lying is intentional deception, and these models are capable of intention or intentional deception. There's a better word for this, because what it really is, the models don't know and don't care if what they're giving you is right or not. There is a word for that, and that word is bullshit. So they will often bullshit us, but make it look very plausible like it's not BS. So this is, so you kind of understand the basic RAG flow, right? There's a question, we vectorize it, we do some kind of query transformation. There's different ways that we can usually do this. We can give the prompt to a language model and say, hey, give me some prompts that are better than what this moron came up with. That's the reason nobody talks about prompt engineers anymore. Because one day somebody just says, you know what, I can just ask GPT to take this prompt and turn it into a better prompt, and it's a better prompt. This is why nobody talks about prompt engineers anymore. Remember, like that was what your kids were supposed to go to college for about like 6 months ago? Yeah.
8 months ago, it was like,
lasted about a week. It lasted about a week. Because somebody's like, oh yeah, just here's the prompt. Somebody's break this down, break down with sequence, solve it in sequence. We can do query rewriting. That's really useful when you're searching these things. Retrieval augmented. What Jim said. So we ask the question, and LLM does some kind of transform. Maybe it breaks it into multiple questions. Maybe it rephrases it. Maybe it tries a bunch of different rephrasing. That goes in the knowledge base, and it pulls out relevant document chunks. Why not the whole document? The context window's big enough. Well, one is cost. Two is, it turns out the more crap that you put in the context window, the quality goes down.
You have in the middle too, you have problems in the middle. It's really great at paying attention to the beginning and paying attention to the end, and it kind of filters out.
Gets lost.
Yeah, it gets lost.
Yeah.
It's kind of funny because I think that's kind of how humans themselves kind of.
Oh, no, 100%. Like, I have an ADD brain, man. You give me the long text, I'm gonna like skim it, and I'm gonna find the wrong things, and then I'm gonna answer in a stupid way. Thank you for hanging with me anyway.
It's great, man. It's great.
So, explain quantum entanglement. Here's the context, and they're just little document chunks. And then you get a response back. Oh, well, that's what that is. Here's a question. How do you know if what came back is good? How do you know if these document chunks are the right document chunks? How do you know if you're not missing something? So your basic RAG flow turns out to be slightly better than just asking the model. And you're still going to get very low quality results overall. And so we look at different ways to do RAG patterns. Oh yeah, we talked about this. We talked about that. We talked about that. We talked about these. Well, I mean, you get this. This is trying to wrap it up for you, bring it home. But we know what the basic RAG flow is. But there's two kind of approaches that are kind of interesting that I'm paying attention to right now. One is self-RAG. And essentially, you have reflection tokens that are generated by a critic LLM after each generation step. And it'll indicate whether the retrieval is required. It'll indicate whether or not retrieved documents are relevant, and whether or not the answer is supported by the documents. So you're basically just chaining more LLMs together. And that's where we're getting the reasoning right now. We're chaining together a bunch of them. And mixture of experts who have different, different tuning and prompting and models to tackle different parts of the problem. But that's basically solving some of the problems we talked about. Another one is corrective RAG, because this is this is kind of important. Because I mentioned I had my blue screen, I Googled, and I went through 10 pages of Google results. And all of them, I got 3 things. I got SEO spam. I got AI slop. It was SEO spam, but it was AI generated, so it gets its own category. And I got Microsoft discussion forum questions that had been retired. That was all I could find. Now, here's the problem, though. Like, if you go out and do a Google search, somebody said to me, it was like, oh yeah, LLMs are like search engines. Like, no, they are not. Do not say that. They are not search engines. You can plug them to a search engine with basic RAG, but here's the problem. You have a coding question, and you Google it, you find Stack Overflow, and you look at it, there's like 10 answers, and one of them has like 150 upvotes, one of them has like 20 downvotes, or net 20 downvotes, and one of them was like 15 years ago. It was about, you know, giving an answer with a product that doesn't exist anymore. And you'll look at that, you look at the dates, you look at the votes, you look at the contents, and you're gonna make some reasoned decisions. But the AI is just gonna take the search result, look at it, and then answer the question, but it doesn't understand any of that context. But it's gonna make it look very authoritative. That's a problem that we have. And that's where we get to corrective RAG. Because corrective RAG is basically, are we already here? Yeah, we're already here. Corrective RAG will actually look at different things that came back and say, yeah, you know what, I think that's correct, I think that's ambiguous, I think that's incorrect. And it would go through all of this stuff. That's my time to wrap this up. We're actually getting, wait, 240 or 279? I'm kidding. And we have agentic RAG. This is where we're basically plugging databases to the things, and there's kind of a lot of interesting stuff in there in terms of basically having agents that can go and talk to these different systems. Just be careful with it. Just be careful with it. But agentic RAG has some potential. And if you really want some spicy takes on MCP and the rest of it, I posted something on LinkedIn last night, and I sent it to Brian Sletton, and he sent me a message back 5 minutes later. He says, "You're getting bold." I said, "Oh." He says, "You just picked a fight with like 5 different, very passionate, very vocal groups of tech people," and right away somebody's like, "You're full of crap." And so, but you can read. I talked about the agentic RAG stuff, and I also linked to a video that talks about a way to make your APIs AI ready, that can build on linked data and all this other stuff, kind of lays it all out. That's a good homework if any of that sounds interesting to you, but we are out of time. So we talked about a bunch of different patterns through here, composite patterns, model tuning, pipeline patterns, choreographed and orchestrated event-driven patterns, serverless, Kappa architecture, RAG, self-RAG, corrective RAG, agentic RAG. I didn't talk about agent-ready APIs, but go ahead. This is your shot. This is it. This is most of what we talked about, but I wanted to present it in useful context because the solution is usually the interesting part, but not the valuable part. The problem that we're solving is how we need to approach these things. In general, oh yeah, go ahead. In general, don't train your own models generally. Just don't rush to fine tune either, let somebody else worry about it.
It costs a lot of money.
It costs a lot of money and it's harder than you think. Serving models, build on top of a foundational model. Most of the abilities apply here. Hallucinations are a feature and a bug, but they can still be a problem even with RAG.
They're fugly.
They are. That's and this is why we have these advanced RAG models, because this is still a problem. This is the hard part. Like building a RAG demo, easy. Doing all this stuff like figuring out what the document chunks should be, whether they're relevant, whether they're ambiguous, whether they're helpful or not, we have to be mindful. The most important thing that we need to understand is these are non-deterministic systems. They're designed to be non-deterministic. And your business people need to understand that they are coming to you and they're asking for deterministic outcomes from non-deterministic systems. That is you just gotta have a bad time. MLOps, like master DevOps, make sure you actually have database backups. And maybe we wouldn't see all these like posts on Twitter or whatever the hell we're calling it today. But if you're not doing MLOps, if you can't do backups and recoveries, then your MLOps is going to be like way harder for you. Do think about Edge AI. Can you strip down a model, send it down to the client, do the inference there? But the main thing is keep it simple at first. And we are not just out of time; we are over time. And there are raffles to do, and there's pizza that somebody needs to take home. So with that, I will say thank you. And before we do the raffle, there's also a special extra raffle. I am an idiot, and I had books to bring and give away and sign and everything. But Scott is like just a good friend, and so he brought me a visual aid. He's not going to give it away because it's his copy, damn it. But this is the book. If you want to be a better software architect, or if you want to move in this direction, I originally had a much less ambitious work in mind, and then the publisher said, we're going to call it Mastering Software Architecture. So I spent another year writing it because I wanted to do justice to that title. Good reviews so far. There's a lot in there. A comprehensive new model and approach to software architecture. So there's something for everybody, whether you are a senior architect who's been around forever or somebody who wants to move in that direction. That is a book for you. I'm giving away 2 copies. They will be signed. They will be sent to you. But because I'm an idiot, I have a raffle form. Fill this out, and I will coordinate some announcement, or I'll reach out to you, and we'll figure it out. That should give you a form. And it's just name, address, email. Like, I'm not even going to email you when you fill it in, so like you might maybe hear from me twice ever, because I'll tell you something, and then I'll tell you one other thing, because I got something really exciting cooking that I'm going to tell you about. Beyond that, I'm not going to spam you. I hate it. I'm not going to do it to you. If you go to my websites, no cookies to track you. There's nothing that's going to drain your battery. It's static HTML, baby. 1993 with HTML5. But anyway, so that's the book. I'm going to send it out to you. I'll send everybody an email, but I will also notify the winners. How many did I say I was going to give away? Two. Okay. Shaggy. All right. Do your raffle. I'm going to pack up. Y'all have been awesome. Thank you for listening to me for as long as this has been. It's way hot. Y'all have been awesome. Thank you. Other questions? I love talking about this stuff.
There's a cool
Static analysis, code analysis, architectural governance, all kinds of good things by our friends at Hello Tomorrow.
Kaiju wins.
Yeah, I could have flipped a coin. I have coins.
I hear you. Well, I'm trying to make this a little more fun here, all right? So,
All right. It should play yakety sax when it spins.
That would be good. But, and this is for IntelliJ.
Only 3 people are intelligent.
Only 3 people were.
Because we're all paying for it because
So this will be
the
Jeff.
boss. Uh-oh.
What?
Well, I'm gonna try, it's just merely a toy at this point.
I'll share my JetBrains Ultimate key with you. I mean, they don't seem to track how many machines it's on.
This is for the WebUK.
Yeah, they'll email it out.
Yeah, just
WebUK we
be
got
sure
here.
you redeem it though.
Yeah.
It really expires
Before
one
you.
day before the deal is because they're over.
Thank you all for
In Europe.
signing up and taking care and joining us. And we will see y'all next month.